Well, good morning, everyone. Thanks for coming to the first talk so early in the morning. My name is Kevin Conley, and I'm a firmware engineer at Pebble. And today I'm going to be talking to you about creating Pebble apps for the Aplite, Basalt, and Chalk platforms. So a fair question is, why target multiple platforms? Why not just focus on the latest and greatest? One reason is that over 75% of our current active Pebble users are still on the original Pebble Classic and Pebble Steel watches. And so if you were to only target Pebble Time or Pebble Time Round, you're missing out on a huge chunk of potential user base for your applications. Another reason is continuity. And this is kind of the argument that if you already have an app targeting the Aplite platform, and a user upgrades to a newer Pebble, and they already have your app in their locker, then if your app is also on the newer platform, it'll already be in their locker when they come to the new platform. So this is great if you want to make sure that your users continue to use your app once they upgrade to a new Pebble. I don't know if you have noticed, but on our developer portal, we now have these icons next to the apps that you publish. And they indicate whether your app supports Aplite, Basalt, Chalk, whether it has an iOS or Android companion app, and whether or not it uses Timeline. So if you maximize the number of platforms that you support and the mobile apps that you support, you can fill in all those icons. And so it's kind of like a cool merit badge thing you can earn. So today's agenda for this talk is, first I'm going to talk about the difference between runtime platforms and SDK versions. I'm going to talk about the differences in color support between all the platforms and how you can best organize your code to maximize code reuse across those kinds of platforms. And similarly for display shapes, with the introduction of Pebble Time Round, we now have a round display shape. And so we'll talk about how to organize your code to work within multiple display shapes as well. And then lastly, we'll talk about SDK compatibility. This is, again, trying to maximize reuse of code in the context of multiple versions of the SDK. So let's start with the difference between runtime platforms and SDK versions. I know this is kind of it can be confusing, and I actually still get it mixed up too. So let's go over what a runtime platform is first. So in Heiko's talk yesterday, he mentioned that a runtime platform is not actually a specific hardware version of the watch. So not specifically like the Pebble Classic watch or the Pebble Time Round, but rather a set of runtime attributes that exist for an application running on a watch. So with that in mind, I want to talk a little bit about Pebble operating system versions. So the original Pebble watches run Pebble OS 2.9. And Pebble Time Steel, and Pebble Time Round will run 3.x versions of the Pebble OS operating system. So with our older Pebble Classic and Pebble Steel watches, those watches fall under the Aplite runtime platform. So it's not that Pebble Classic or Pebble Steel is specifically like they are the definition of Aplite, but rather they fall under the Aplite runtime platform. And again, Aplite currently only runs the 2.x operating system, but coming very soon is 3.x for Aplite. And so the Pebble Time and Pebble Time Steel watches, those fall under the Basalt platform. And so they run on the 3.x Pebble operating system, and they do not run the 2.x Pebble operating system. And now we have Pebble Time Round, which falls under the Chalk runtime platform. So both Basalt and Chalk run this 3.6 operating system that you guys have been given for the developer retreat. But Aplite does not run 3.6 yet. Coming soon will be a 3.x operating system for Aplite. And so I mentioned that Aplite, Basalt, and Chalk are runtime platforms, and that's really the set of runtime attributes that they have. But part of that is what hardware is available for those platforms. So I'm sure you guys are familiar with a chart similar to this, basically detailing the resolution, display shape, color support, CPU, memory. These are what I mean by attributes when I talk about the definition of a runtime platform. So again, if there's anything else you get from this part of the talk, it's that Aplite, Basalt, and Chalk are runtime platforms, not specific hardware models, nor are they SDK versions. But now let's talk about, let's see. Right, and this is just reiterating that we'll have a unified 3.x SDK later this year, and all of our Aplite, Basalt, and Chalk watches will be running 3.x at that point for the operating system. Okay, and so now I'd like to talk about SDK compatibility. So there's a difference between the version of the Pebble operating system that a watch is running and the SDK version that an app is compiled against to run on that operating system. This chart aims to illustrate that in the context of Aplite and Basalt. So if we take a look at this, we know from before Pebble Time was released that you can compile an app for the Aplite runtime platform using the 2.x SDK, and it will run on Aplite watches running the 2.x operating system. So that's pretty easy. But when Pebble Time was created and when it was developed, it was also engineered so that it would continue to run 2.x Aplite compiled apps on the 3.x operating system on Basalt runtime platforms, which is the Pebble Time and Pebble Time Steel. So that this particular check mark is representing that backwards compatibility. But the converse is not true. It's apps compiled for the Basalt platform using the 3.x SDK will not run on the 2.x operating system running on Aplite watches. And then finally, this one's pretty much just identity. Apps compiled against the 3.x SDK for Basalt watches do run on the 3.x operating system for Basalt watches. Okay, so let's add another dimension to this compatibility matrix. With the introduction of Chalk, we just have one more row and column. And it's pretty much the same idea that 3.x compiled apps for Chalk will only run on 3.x operating system Chalk watches. Okay, so that takes care of sort of explaining what we mean by Aplite, Basalt, and Chalk, and what different SDK versions are available. And now I'd like to talk about colors, which is one major difference between some of our platforms. So Aplite, that platform only has support for black and white. That's true right now. With the introduction for 3.x for Aplite later this year, an additional dithered 50% gray color will be added to the SDK. Basalt and Chalk actually have support for a 64 palette, or 64 colors. And if you haven't seen it already, on our developer website, there's a color picker tool you can use to check those colors out. And it basically looks like this sort of hexagonal grid. And you can also download color palettes for a lot of popular image editing programs. And I also wanted to give a shout out to Matthew Reese's open source dithering library, which uses some dithering algorithms to provide some additional shades of color on both Aplite and Basalt and Chalk platforms. So what this means is that on Aplite, you'll get some shades of gray between black and white already, and on Basalt and Chalk, with different shades of color combinations, you can actually achieve over 300 different colors beyond our normal 64 color palette. And the idea behind dithering here is just that dots are drawn very closely together, and it creates an optical illusion of different shades of colors. So here's a pop quiz for everybody. If you've used our 3.x SDK, you might have seen this macro before. Color fallback is a preprocessor macro that provides a way of specifying two different values that should be chosen based on color support. And so I'm wondering if someone can tell me what the two different arguments here mean. Does anybody remember?
The first one is the color, the second one is the black and white.
That's exactly right. First one is the value that you want to be chosen on platforms that support color, and the second one is values that you want to be chosen on platforms that only support black and white. But That's not very easy to remember just from the name of the macro. And so with the latest SDK, we've actually deprecated color fallback. Please don't use it anymore. And instead, we've introduced some new macros. There's Pebble if color else and Pebble if BW else. And hopefully these macros are a little bit more clear what the order of the arguments represent. But these are two macros that we hope you'll find useful in organizing the code for your apps to support different levels of color support on different runtime platforms. And similarly, we've provided Pebble color and Pebble BW defines. And so these are useful if you have more than just a simple expression or value that could fit in those previous macros I mentioned. You can use these in if-def blocks to block out different sections of your code to run under the context of different levels of color support. We also have color-specific resource processing. Heiko mentioned this a little bit in his talk yesterday, that you have these tilde suffixes you can add to resources that you want to include in your app. And so in appinfo.json, you have a single entry for the resource file name without any tilde suffixes. And then the actual files as they exist in your file system should have these tilde suffixes to indicate different levels of color support. So we have BW for platforms that only support black and white, and color for platforms that support color. And then another useful thing in terms of colors on multiple platforms when you're writing your applications is you might want to actually theme your app's UI around the color of the watch that it's running on. So we provide this API, watch info get color, and that will return an enum value that specifies the color of the watch model that your app is running on. And so at runtime, you can use this to, for example, if we have a text layer and we want to set a specific text foreground color and text background color, perhaps for the Pebble Time Steel Gold watch, we want a white text on a red background, and on the Pebble Time Round black watch, we want a white text on a black background. And then the code at the bottom just sets those two colors appropriately. So this is a great way that you could theme your apps around the color of the watch that you're running on. So that's kind of a rundown of some different considerations for different levels of color support on our runtime platforms. And now I want to talk about different display shapes that you might encounter on runtime platforms. So I'm sure you're all very familiar with the rectangular shape that we support. On the Aplite and Basalt platforms, it's a 144 by 168 pixel resolution, and that's represented by the blue rectangle here. Now with the introduction of Pebble Time Round in the Chalk platform, we also have a round display shape. Its frame buffer is actually the 180 by 180 green square here, but of course only a subset of all of those pixels are actually visible. And if you do the math, the round display that we have actually has 7% more visible pixels than the rectangular display. So this is going to create some interesting issues for the layout and graphics drawing of your applications. And I wanted to illustrate that with an example. So let's say we've written an app for the Pebble Time on the Basalt platform. And all it does is it writes hello world in the center of the screen. Now if I take the same code and I run it on a Pebble Time Round, the text is no longer centered in the screen. Does anyone know what the issue is here?
You set your width to 144.
That's right, which is the width of our rectangular display. And yet the Pebble Time Round watch with its round display has a 180 by 180 resolution. And so that's why it's misaligned. It's drawing it exactly the same on the Pebble Time watch, but that just happens to have a display that makes it look centered. And so that's right, that's the exact issue. Now what we can do to fix this is we can write some code that actually calculates the frame of the text layer with using the root layer of the window's bounds. Sorry, the bounds of the root layer of the window. And this is going to be different at runtime for the different display shapes. So this is actually a way that you can make sure that your text is centered regardless of the platform that it's running on. And the basic idea here is So we've already got our root window layer. We call layer get bounds to get a rectangle of its bounds. We use a constant height of 20 for the text, which is just kind of the idea that a single line hello world should fit within 20 pixels height. And then we calculate the y coordinate of the text frame's origin by saying that the height of the window minus the text height divided by 2 will center the y coordinate, taking into account the height of the text as well. And then finally, we construct our text frame with an x origin. So actually, the x origin point is here. And then we use the text frame y, which makes sure that it's at this y coordinate. And then we've got the whole width of the window for the size. And then the height is just the constant 20. And then because we set the text alignment to center before, that will actually center the text in the screen. So this is great. We can center text in an arbitrary display shape. But this is kind of a lot of code to do that, and more math than I'm sure some of you would like to do in something so simple. So we provide some utility functions that can help you out with this. One is called grecalign, and this is a function that allows you to align one rectangle within another. And there's some and there's some arguments here as well. So the first one, alignment, is an enum value that specifies how you want the rectangle to be aligned within the inside rectangle. And then there's also a second argument, clip, which specifies whether or not you want the rectangle to be clipped to inside rect after alignment. So to illustrate this function, I have two examples. In the image on the left, we have the rectangle, which is this sort of teal rectangle here. And we use galign center to center it within the inside rectangle. Now you'll notice that the width of the rectangle exceeds the bounds of the inside rectangle. We've set clip to false here, and so that will not actually be clipped to the inside rectangle. In the example on the right, we're using galign top, which will align the rectangle at the top center of the inside rectangle. But we set clip to true, which means that even though the original rectangle had an x coordinate that was outside inside rect, or overall just a larger width than inside rect, setting clip to true here will actually clip it to inside rect. And so basically what this function is doing is by passing in a reference to each of these rectangles, the result is that the rectangle's origin will be modified by this function so that it's centered. And its size may be modified if you decide to clip it.
But that's only for rectangles.
Correct.
Maybe you're going to cover it here. But if I've got text, then it won't necessarily be centered within the rectangle because of the baseline and all that sort of stuff.
That's correct, yes. And actually, we can talk a little bit more about that at the end of the presentation to cover that. So I mentioned there's a galign enum that you can use to pass into this function. And this grid illustrates what all the different values of that enum represent. So we talked about galign center for the center, galign top for the top center. Then we also have top left and bottom right, and hopefully that's pretty easy to understand. Another useful function that we provide for sort of positioning rectangles relative to other things or just modifying them in a way that's hopefully saves a little bit more code on your part is the grect inset function and its accompanying macro gedge insets. And so this is a function and macro that allow you to inset a rectangle by a certain amount of pixels on all of its sides. So the first argument is the rectangle you want to inset. The next argument is a gedge inset struct, but you can use this macro to easily create it. And it follows the rules of CSS margin and padding in terms of the number of arguments and their meaning. So if you only pass one argument into gedge insets, then that will inset the rectangle by that amount on all sides. So top, bottom, left, and right. And so for this example A, we're insetting this rectangle by 16 pixels on all sides. And the two argument, three argument cases are illustrated here, top and bottom, right and left for the two argument, and then top, right and left for the second argument, and bottom for the third argument. But something to remember is that you can also pass a negative inset for any one of these values. and that will actually extend that edge instead of insetting it. And so in the D case here, we're actually extending the right edge by 20 pixels. And so you may have done code similar to this already in your apps, basically adjusting maybe the x-coordinate and the width to sort of to inset something or move it forward. And this function will hopefully just help simplify the code required to do that. And I also wanted to mention a function grec centerpoint that allows you to calculate the center point of a rectangle. And this is another hopefully useful way of determining the center of something so that you can align other things with it. And yeah, it's pretty straightforward, just returns a G point. So cool. We've learned about some utility functions that will simplify our code so that we can write code that hopefully aligns things and looks nice in the context of multiple displays. But what if we actually have a completely different implementation depending on display shape? Well, just like we have our Pebble if color else and Pebble if BW else macros, we also provide a Pebble if round else and Pebble if rect else macros. And yeah, it's basically the same idea. Depending on which macro you use, the first value will be used if that shape is present on the current runtime platform, and otherwise the second value will be chosen. So in this example here, maybe we want to calculate the area of something. And on a round display, we want to calculate the area of a circle within a rectangle. And so we calculate area using pi r squared, where r squared is in terms of the width. And then on other displays, we might want to calculate the area just using the rectangular area, using width times height. So that works great for simple expressions or literal values, but what if you have multiple lines? Well, just like we have Pebble color and Pebble BW defines, we also have Pebble round and Pebble rect defines. So Pebble round will be defined on round display platforms, and it will be undefined on other platforms, and same for Pebble rect. And so yeah, in this particular example, on a round display, we decide we want to fill a circle, and on other displays, we want to fill a rectangle. So we're choosing a different implementation based on the display shape at runtime, or sorry, based on the display shape of the runtime platform we're targeting. And so that works great for maybe a couple lines, but what if you start to have an implementation that's more than maybe 5 lines? Well, at that point, we recommend you actually break your code into multiple functions. And you might choose to use a underscore rect or underscore round suffix for those functions. And then once you've done that, if you happen to use the same number and types of arguments for those two rect and round functions, and they have the same meaning, you could actually use the Pebble if rect else or Pebble if round else macros to choose the function that you want to use, and then just pass the same set of arguments to both. So you get a really nice, clean representation of which implementation you want to choose. Of course, that doesn't always work out. You might just have different numbers of arguments, or it might be a completely different implementation. So ultimately, you can still use the if-def Pebble rect or if-def Pebble round idea. Cool, so that works great for multiple functions, but what if you have so many functions that just becomes hard to manage? Well, you can sort of go one more level of abstraction and use files. And this is the idea that you would have a, in this particular example, let's say our module is called file. Well, we can create an underscore rect version with C and H implementation of header files, and then also a underscore round version, same idea. And there's a couple different ways you could do this. You could have, so underscore rect and underscore round versions, and then also a file wrapper, or sorry, a wrapper for those modules that doesn't have an underscore suffix. And within these files, you would actually have an API that simply chooses the rect or round implementation based on the Pebble rect or Pebble round defines. Or alternatively, if you actually use the same API in your rect and round files, in the client code, you could just use the Pebble rect and Pebble round defines to choose which header file you include. But it's important to mention that by default, the Pebble SDK system will try to just compile all the C files in your source directory. And so if you wanted to use this particular method, that would require if-defing out the implementations in the .c files for the rect and round .c files based on the display shape. Otherwise, you'll get linker errors. And then similar to color-specific resources, we also have display-specific resources. And you can actually combine the suffixes of color, BW, rect, and round to really get very specific with how you want to use each of your resources in your application based on the display shape or color support. So in this example, I have a image tilde rect.png, and that will be used for any platforms that have a rectangular display. And I also have a color and round.png file. And this resource will be specifically used on platforms that both support color and have a round display, which right now is just the chalk platform. It's the same idea. You still have a single entry in your appinfo.json resources JSON, and yeah, basically the most specific resource will be used depending on the suffixes you use. And if there's any ambiguity, for example, if you have both a tilde rect resource and a tilde BW resource, then that could, no, actually I think that example would be okay.
No, that's not okay.
That's not okay?
Classic Pebble, you both qualify, right?
That's right. Yes, so basically there are some combinations of suffixes you could use that would be ambiguous to our SDK build system. So if you happen to get an error, just think about if there's sort of conflicts in the suffixes you use. One particular thing to keep in mind when designing your applications for round display support is that there's a 2-pixel margin around the perimeter of the display. And as Heiko mentioned yesterday, this was introduced to cover the edges of pixels of the round display mask, as well as to hide the air gap so you can't look at an angle and see the edge of the display. And in our SDK emulator, we actually show this with a shaded ring around the edge. I don't know if you guys have noticed that. And that's just kind of a visual tool to help you see where that margin extends. But some important things to keep in mind with this 2-pixel margin is that you should make sure to extend the background colors of your applications all the way to the edges of the display so that you know for sure it's being covered regardless of the margin. And then also, we recommend that you avoid thin rings near the borders of the display because if there's any variations in the manufacturing quality of the watch, then it will be very apparent to the human eye that it's off-center. So instead of thin rings near the borders of the display, we recommend either thick rings or that you inset from the edges of the display so you don't have that issue. And so I want to encourage all of you to think about, for your applications, how you can best take advantage of the display shape in designing your apps. As an example, this is the Caltrain app by Catherine Berry. It's open source on GitHub if you want to check out the implementation and see how she designed her code to support different display shapes. But I wanted to point out that we have the exact same content on both the rectangular and round display, but the UI is completely different. And we have a nice sort of ring that if you press the up and down buttons on the watch, you'll sort of go around this ring as opposed to the menu layer used on the rectangular display. So it's kind of a really nice use of the round display when moving to that platform. Okay, cool. So we've talked about color support and we've talked about display shapes as far as targeting multiple platforms. And now I want to talk about the sort of the effects of different UI components in some of our different platforms and SDK versions. So let's start with the status bar. If you've written any applications for the 2.x version of the SDK, then you probably remember that the status bar is not actually a UI component, but rather it's something that you can turn on or off. And if you happen to have it on, which is the default, it will actually just inset from the top your root window layer bounds by the height of the status bar. And if you do want to turn it off, you would use this function window set full screen and set the window full screen to true. That changed with the 3.x SDK. Now status bar is actually a layer. It's a UI component that you create yourself, you configure it, and then you add it to the layer hierarchy just like any other layer. So if you want a status bar for an application that targets both Aplite and Basalt or Chalk right now, because 2.x is the only SDK for Aplite right now, you will have to choose to either set the full screen to false, or that is the default to have a status bar, or to create a status bar component and configure it and add it to the layer hierarchy. And you can use we have a Pebble _SDK_2 and a Pebble _SDK_3 define, and I'll talk a little bit about that in a moment. But in addition to simply the APIs based on SDK version, status bar actually has a different look on rectangular versus round displays. So on the left, we have a rectangular display, which is giving the status bar layer a height of 16 pixels. And on the right, the status bar layer has a height of 24 pixels on a round display. So this is important when you're laying out the UI of your application, that you take this into account and that you don't rely on any hard-coded values for the status bar layer height, but rather actually use the define for status bar layer height in laying out your UI code. And you can actually take advantage of that grect inset function that we mentioned earlier to very simply inset your content. In the case of a round display, you might want to do that for both the top and bottom by the status bar layer height. And by using the gedge insets variant with just 2 arguments, we can very easily do that because the first argument represents top and bottom inset, and having a 0 for the second argument just means don't touch the left or right sides. Another UI component that's different between rectangular and round displays is the action bar. It has a different look on the round display. It's kind of this semicircle. And then also its width is different for both rectangular and round. So on rectangular, we've got 16 pixels, and on round, we've got 24 pixels. Or no, sorry, I read that wrong. That's the height of the status bar layer there. On a rectangular display, it's a 30 pixel width, and on a round display, it's a 40 pixel width. And this is what it looks like on a round display with an actual watch. And so although these icons look a little bit off-center to the left, in the context of the bezel and the 2-pixel margin, actually it looks centered on the actual watch. And so same idea, we can once again use our grect inset function to calculate the rectangle illustrated by this lower left rectangle here. The basic idea is you want to inset by both the status bar layer height from the top and the action bar width from the right. And we can use that with the 4-argument version of the grect inset function, where this is the top, this is the right, and then for left and bottom we use 0 pixels. Another component that's different between rectangular and round displays is the menu layer. So on a rectangular display, a lot of common styles of the menu layer is that all the cells have the same height, and when you scroll through the menu layer on a rectangular display, the focused or highlighted region will move across the full height of the display. But now on a round display, by default, menu layers are center focused, and that means that the highlighted or focused region stays static in the window, and the content simply moves up and down within it. And to achieve some of these different styles of menu layer, we've added defines for different cell heights that you might want to use. And the basic idea is that if you want to have a different cell height for the focused area, that you should use we use the convention short and tall. And so if you want to use a short focused cell height, then you should use a tall unfocused cell height. And on the other hand, if you want a focused tall cell height, you should use a an unfocused short cell height. And for some menu layers on a round display, you might actually just want all the cells to be the same height. And for that case, you can still use menu cell basic cell height for those cells. So that's great, but how do you actually choose a different cell height based on whether a cell is focused or not on round displays? Well, you have your get cell height callback that you provide to the menu layer, And you can take advantage of the Pebble Round define to know whether or not you're running your menu layer on a round or rectangular display. And if you're on a round display, we have this function menu layer is index selected that's introduced in the 3.x SDK that allows you to pass in the menu layer and the cell index, which is one of the arguments you get for the cell height callback. And that will tell you whether or not the cell is the focus cell. And if it is, you can pass in your focus cell height. And if it's not, you can pass in your unfocused cell height. And then on non-round displays, you can just continue to use the basic cell height for all of the cells. And then we also have a menu layer set center focused function that is true by default on the Chalk platform, but you can turn it off too if you want to. And this specific example talks about the cell height callback, but you would also need to choose a different way of drawing the cell in the draw row callback based on whether or not the menu layer, based on whether or not the cell index that you're drawing is currently selected, which again, you would use the menu layer is index selected function to determine. Text layer is a component that is sort of radically different between a rectangular and a round display. And it's basically the idea that you want to take advantage of as much real estate of the screen that you can. And on round displays, you can't just draw text as if it were in a rectangular frame. Heiko talked about this yesterday, but the basic idea is we have this new text layer enable screen text flow and paging function. And you pass in a text layer and an inset that allows for some more padding, and that will automatically flow your text with the shape of the display. And in this example, we're using 8 for the padding, which just means we'll have 8 pixels on all sides of the round display or also rectangular display, if you were to call this on a rectangular display. And it also enables paging, which is important because if you were to scroll a text layer on a round display without paging, then the text would reflow as you scroll, and it just looks kind of weird. So by calling that function, you also enable paging, which means that your text layer will be scrolled by a full page worth of text content as opposed to just a few pixels, which would incur the text reflowing. I also wanted to mention, similar to the previous slide, where you could inspect the color of the watch model that your app is running on. You can also inspect what watch your app is running on. And this may be useful if, for example, you wanted to lay out UI components such that they're aligned with the buttons on the watch or some other aspect of the watch. In this example, we want to align this menu cell with, or rather just this rectangle, it doesn't necessarily have to be a menu cell, with the center button. But those screen coordinates for the center button are actually at different, they're different coordinates from the Pebble Steel watch to the Pebble Time watch. And so using watch info get model, that will return a enum value that we can have a switch statement to choose where we want to draw those rectangles. Cool, and so the last thing I want to talk about is SDK compatibility. A sort of common thread of this talk has been how can we maximize our code reuse when we're targeting multiple platforms with our applications? And one consideration of that is the different SDKs that you might be targeting. Right now for the Aplite platform, you're still using the 2.9 SDK, and or rather it's targeting the 2.9 operating system. And that means that some APIs that are available for the Basalt and Chalk platforms are not yet available for the Aplite platform. We do provide some defines for the platform that your app is currently running on, or rather that will compile the code. I keep getting it mixed up too, but all of the defines are at compile time. It's not a runtime specific thing, but these will allow you to choose code based on the platform you're targeting at compile time. But we recommend that you don't use these under most circumstances. A lot of times you're probably designing your app or writing code such that you want different implementations based on whether or not you have color support or whether or not you have a particular display shape. So it's better to use Pebble Color and Pebble Round and those kinds of defines instead of these platform-specific defines. Because, for example, if you wanted to have a specific implementation for color support, if you were to do that in terms of platform defines, you would have to say if def Pebble Platform Basalt and Pebble Platform Chalk, and that just gets kind of messy. So these defines are better to use if you're specifically trying to take into account display shape or color. But there are some use cases where you might want to use these Pebble Platform defines. And those are specifically when you need to use a particular implementation that is specific to the CPU of the hardware platform that you're targeting, or if your implementation is sensitive to the memory that you have available on that platform. And just like we have color-specific resources and display shape-specific resources, we also have platform-specific resources. And there's two ways you can specify this. One is using the target platforms entry in your appinfo.json, which allows you to specify a list of platforms, Aplite, Basalt, and Chalk, or any variation. And you can also use ~Aplite, ~Basalt, and ~Chalk suffixes for your resource files. But again, in most cases, you're probably actually going to want to use different combinations of rect, round, BW, and guller suffixes, because that's just more explicit if what you really care about is display shape or color support. So I mentioned that some functions just don't exist on the SDK we currently have available for Aplite that do exist on the SDKs that we have for Basalt and Chalk. You can use the idea of a shim to help bridge this gap. And a shim is traditionally just like a small library that helps provide functionality that doesn't exist on one platform in the context of a multi-platform application. So in this case, we're defining a function, shim gpoint from polar. It's a function I want to call for my application's code without caring about the SDK that I'm compiling against. I just want to be able to use this functionality. And so we can use the Pebble SDK2 define, which will be defined if we're compiling against a SDK2 version of the, a 2.x version of the SDK, and it will be undefined otherwise. And that way we can choose a specific implementation to calculate a point on the perimeter of a circle at a certain angle. Or if we're not running Pebble SDK2 and we actually have that function defined in the SDK, we can just call the SDK function. I want to point out that these two implementations will not actually return the same values, and that's because the gpoint from polar function in the SDK takes into account half pixel distances, whereas this implementation is only in terms of full pixels. So you wouldn't expect them to return the same values, but if you wanted to have a similar functionality for both the version of your app compiled against SDK2 and the version of your app compiled against SDK3, shims are a way that you can provide that support. Another thing you have to consider is the JavaScript that you write for your applications. If you're targeting older watches that are running or that use the older Pebble mobile app, then not all of the newer APIs for PebbleKit.js are available. And so it's good to always check if the JavaScript function is actually available before using it. And if it's not available, that you fail gracefully in your application. So one example could be that you are trying to get the active watch info, which from JavaScript will tell you what watch your app is running on. Well, that won't work on older platforms, the older Pebble mobile app. So it's good to gracefully handle that situation. A similar idea exists in the code you write for the watch. Some of our newer APIs, which provide services like, for example, dictation for the voice APIs, return a pointer, in this case, to a dictation session. And that pointer might be null, and it could be null for a variety of reasons. It might be null if the platform doesn't actually support dictation services. So when 3.x is released for the Aplite platform, which doesn't have a microphone, this API will be available, but you can't use it because there's no microphone. And so that function will return null if you use it. This function can also return null if there's simply not a phone connected, which is required to get a transcription of any voice data. And then also if you haven't set permissions on your phone to enable that functionality, then this function could also return null. So overall, it's always good to check if a function returns null and handle that case so that your app doesn't crash because you try to use a null pointer. There's also some considerations for the iOS and Android libraries that you use with your app. Basically, starting with Chalk, you need to compile with the PebbleKit iOS 3.0 version. And with Android, you've needed to do that since PebbleOS 3.0 was released. Marcel is actually going to give a talk later today about this. If you want to attend, it's going to be at 1 p.m. It's kind of just an extra interesting point. You can run multiple instances of the emulator for the different target platforms so that you can see your app running on all 3 platforms at the same time, and this can help testing. This can help in testing what your app looks like on all the platforms and see them side by side. And the way you do that is you just run the pebble install -- emulator command, giving it Aplite, Basalt, and Chalk with each instance. Yeah, and that'll open 3 QEMU windows, and you can see your app running on all 3 platforms. And you can also use this method to automate taking screenshots for uploading to the App Store. With all 3 emulators open, just run the Pebble screenshot command over and over again for all the platforms, and you just get 3 screenshots really easily for your 3 platforms. So to recap, today we talked about the difference between runtime platforms, SDK versions, and also what that means in the context of different versions of the Pebble operating system running on the watch. We also talked about how to organize and structure your code to support different levels of color support as well as display shapes. And we also talked about how you can, some techniques you can use to try to maximize the reuse of code in the context of different SDKs that you compile against. And so this is the end of my talk, and this time I want to thank everybody for coming out and listening and staying awake even though it's so early in the morning. And yeah, I'd be happy to take questions at this time if you have any.
This is, I guess, the point where I find out whether I really understood.
Sure.
If you go back to that slide where you had the shims,
Sure.
Am I right in understanding that basically whenever the 3.6 SDK is available for Aplite, that won't be necessary because all the functions will be available, but some of them will return things we have to check. Is that correct?
That's correct.
Right.
And so shims are kind of a way of bridging that functionality until it exists. At that time, you could remove all your shims, and hopefully, if you have a similar signature, it won't be too difficult.
Right.
Hopefully they will go to 0 over a period of a couple months.
And for the purposes of the video, because I don't know if all the microphone audio was captured, the first question that was asked was, in the case of the shims, will those still be necessary, or can those be removed once the older platforms support the newer SDK with all the APIs? And the answer is yes. And then another question that was just asked is, what does this mean for the older Pebble Classic watches getting upgraded to run the 3.x operating system? Brad answered basically that we're going to be giving users the option to upgrade, and it's going to be sort of a slow rollout, but that ultimately the Pebble mobile app, if your app does not support the newer version of the SDK for that watch, it will just provide the older version of the app running the older SDK version. And once you do upgrade once you provide a newer version of your app compiled against the newer SDK for the older watch, then that version will be provided. And so there won't be any issues for users.
So is that live now? So if I were to submit a version of my app that's for SDK3, and I push that, it's going to keep that old 3.4 version?
We haven't implemented that yet.
Okay.
And also, to start, we're just going to do it for a 2.0 versus a 3.0 era, as opposed to...
That's what I meant, yes. So like my 2.0 Aplite app is sitting there now. If I were to kind of, submit a compatible 3.6 version, it wouldn't overlap it, I guess, for the...
Once you...
So, but not yet.
Not yet.
Not there yet.
And we'll have more instructions as 3.0 becomes out available, as we release that SDK. And we'll go.
Cool. And for the video, that question was, do we already support the ability to provide older versions? And the answer is no, not yet, but coming soon. Any other questions? Cool. Well, thanks again, everybody.